Welcome to another video. I want to show you how I solved this equation. I believe it came in a math competition in the year 2020 because I'm looking at this number here. 2020 is a weird number for you to put as the base of a logarithmic equation. But it's actually fascinating, and I was working through it and then I came across something beautiful. And then I knew I had found the answer. I just needed to show that that was the only answer. Let's get into the video. So the first thing you want to observe is that you have a logarithmic expression or function on the left-hand side, and it's equal to another logarithmic function. But this one makes our life a lot easier because it is just the logarithm of x in base 2. So what I can do is say that, well, if this is equal to this, but we don't know what either is because we don't know what x is, we might make things simpler by saying that this equals this and it's equal to t. Okay? And because I don't want to keep writing this, I'm just going to make this be equal to some giant x, okay? So I might say, maybe I shouldn't use x. Okay, let's say, let y be equal to, I'm gonna copy and paste. So if y is equal to this, I can rewrite the entire problem this way. I can say, then, we can say that the logarithm to base 20 of y is equal to the logarithm to base 2 of x, and let's say it is equal to some t. Okay, this is going to help us a lot because you see, I'm going to make certain claims using the connection between these two and these two, and that way I can, Okay, so let's start with the easy one, the most obvious one. Look at this. Log x base 2. Remember, you can only put non-zero values as the argument of a log function. Okay? By the way, we're solving for real solutions. Okay? No complex numbers here. So this has got to be non-negative, and it cannot be 0 either, right? So x must be greater than 0 by the definition of the logarithmic function and the domain of the logarithmic function. Okay, we know x is greater than 0. Okay, x definitely is greater than 0. It doesn't matter how you describe it, because even if you don't follow the definition of the logarithmic function, by definition, if this is equal to t, it basically means that x is 2 to the t, okay? We also know that x is equal to 2 to the t, and any exponential function is not negative if the base is not negative, and it is not 0, so x is greater than 0, however you look at it. One more thing to notice is that if you equate this to t, you can also claim that y is 20 to the power t. Also, y is equal to 20 to the power t. So, what exactly is y? We said y is this guy, right? So, I can write y also using t as the variable because I know that x is 2 to the t. So, I can, instead of writing x, I can write 2 to the t in all of these cases, okay? So, I can say, so y will be equal to, instead of x to the 10th, it's going to be 2 to the t to the 10th plus 2 to the t to the 9th plus all the way to, what's this one? It's going to be 2 to the t squared, right? Yeah. So it's going to tell me that y will be equal to, so I can move this in, that becomes 2 to the 10 to the t. I don't want to, okay, let's just write it. That's 2 to the 10 to the t plus 2 to the 9 to the t plus, it goes all the way to 2 squared to the t. But one thing I know is, you see, I can factor out 2 squared, which is basically 4, right? So I can factor out 2 to the, this is 4 to the t. You know, that's a better way to write. I'm just going to write this as 4 to the t. Okay, so you can see it. But it's 2 squared. So it's 4 to the t. Now, if I factor this out, I'm trying to see if I can get something smaller that I can relate with. If I take this away, to factor this, this is going to be 4 to the t multiplied by, see, 2 to the 10. If I take 2 squared away, it's going to be 2 to the 8t. 2 to the 8 to the t plus 2 to the, this is going to be 7 to the t plus all the way to, this is just going to be 1. Okay, I don't want to write all of them yet, but I'm still going to write them out. Notice that we're missing x to the 4th and x to the 3rd here. They're missing. It was intentional so that the answer will be possible. Okay, so here, what do we have? That's 2020 to the t, 2020 to the t. So I can divide both sides now by 4 to the t, so that what I have is going to be just this. What is 2 to the 8th? 2 to the 5th is 32, to the 6th is 64, to the 7th is 128, 2 to the 8th is 256. So that's what I'm going to write here. So I say that I don't want too many equal signs. So what I have is, I'm going to divide both sides by 4 to the t. So I have 256 raised to t plus, this is going to be a power less, which is going to be half of this, which is 128 to the t plus 64 to the t plus 32 to the t, well, plus 16 to the t, 1, 2, 3, 4, 5. See what I just did? I have written out everything I have, and I have this. Do you think it is possible for us to find what t is? Yes, this was by observation. I know some people say you cannot do math by observation. That's a lie, because by observation, you could see that if I add 256 to 128 to 64 to 32 to 16 to 8 to 1, it gives me 505. Observe that 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 1 equals 505. It is impossible for you to have this expression equal to that same sum raised to power t unless t is 1. So the only way this can be true is if each of these has an exponent of 1. Okay? Fact. A plus B plus C plus 1 is never equal. Raised to power t is never equal to a to the t plus b to the t plus c to the t plus. Never. Unless t is equal to 1. That was my observation. So you cannot add up all of these terms and still get the sum to a power. Is like a binomial expansion. The two sides are never equal. right? You can't just plug in numbers and say, I know some people try to say, look at this. You cannot say that a plus b squared equals a squared plus b squared. We know this is never true. The only time that a plus b squared is equal to a squared plus b squared is no time. So the exponent has got to be 1. Now, if the exponent is 1, then both sides can be the same. That's what I'm saying. The same thing here. This is even worse. So, unless t equals 1. So we know t is equal to 1. And if t equals 1, top, we found our x, and that's the end of the solution. So, since t is equal to 1, x equals 2 to the t, which is equal to 2 to the 1, which is equal to 2. Therefore, x equals 2 is the only solution. Now, is it possible for there to be another value of x? Look at it. I took my time to quickly write it. There cannot be another positive real root according to Descartes' rule of signs. The rule of signs says that if there is only one sign change, the maximum number of positive real roots is 1. So x can only be 2 for this polynomial equation. Let's say instead of me writing it in terms of t, if I had left it this way, the equation we would have had would be, no matter what number you choose for t, this number here is going to be positive. When you move it to this side, it's going to be negative, and that will be the only sign change. It's going to be from positive to negative. So because there's going to be just one sign, okay, maybe I should write it like that. Minus t equals 0. You see, this is a polynomial equation by Descartes' rule of signs. Just because there's one single sign change, there's going to be a maximum number of positive real roots of 1, and we already found it. So you cannot find another positive number that satisfies this equation no matter what value of t. So even if you argue that t equals 1 is not the only solution, well, it doesn't matter. Get that t, plug it in, you will only get one answer. And since we already found x to be equal to 2, never stop learning. Those who stop learning, stop living. Bye-bye.